Hello, everyone. It's nice to have you all here. My name is Amir Isa, and I work for HortonWorks based in Canada, and I am a senior consultant. Most of my focus has been on security and DevOps tools. I know it's been a long couple of days for you guys, and I think this is one of our very last sessions, so I'll try to keep it light-hearted and keep you guys interested. Today, we'll be talking about building a data-driven authorization framework. This conversation might not be very comfortable for some security administrators here, but we'll hopefully convince them at the end and they'll be able to accept change. So how many here actually work for a highly regulated industry that requires high security? So like banking, insurance, pharma, as expected. Those are usually my favorite clients because they give me the hardest challenge and they force me to come up with new innovative ways to solve problems. So brief information about me. Like I said, I work for HortonWorks. I am a senior consultant, or you can say a architect. My specialization is in the platform engineering, so I build up platforms. I deal a lot with the automation piece, and my other specialty is in security. Usually the two don't mix together very well, automation and security, but we try to make that happen. Usually just to shorten the time it takes to bring clusters up in a secure manner. Within HortonWorks, aside from being a consultant, I also act as an SME, subject matter expert for when it comes to anything that comes to security and DevOps. As an introduction to what we're going to be talking about today, we're going to be talking about building a data-driven security framework. So there's a lot of changes that's currently happening with the environment. And when you're building a data lake, you are really collecting a lot of pieces of data and inputting them into one single location. That, of course, offers your cluster or your data lake as a very valuable asset to attack, either from internal or external attacks. And also what ends up happening now is that your operations team or your administration team would not be able to handle the amount of incoming requests. As you are a centralized data lake, that means your consumers and line of businesses across the entire enterprise will be asking you, can you provide me access to this? What do you have in your data lake? Can I have access to that? And within the Hadoop ecosystem, the other issue that comes up is that you have multiple services and multiple layers and multiple ways to access the data. So it could be an HDFS table, it could be an HDFS file, an HBase table, a Hive table, it could be a Kafka topic, it could be an AFI processing group, or it could be a Solar index. So the depth and the variation of the services available and the way to access the data kind of makes it hard for system administrators to be able to go in and manage tens of thousands of policies across multiple services. What we are going to be discussing today and looking through a small demo is how to really switch the narrative. How do we switch the narrative and assigning the right roles and permissions to people who know data best in order to be able to manage permissions and controls across the cluster. And this is exactly my second point. It's how do we allow your data stewards or your line of businesses, people who really understand what the data is, what it means, and now with the GDRB and all these security settings that are coming in and standards, it becomes really hard for a system administrator to take responsibility and ownership of assigning the right permission and the right access control to the data. And how many here have policies that have not been checked or reviewed once a year? Do you have a process within your organization that says, we're going to take all the policies, we're going to review them every year and make sure that the policies we have are valid? Yep. And when you have 10,000 policies, which I've seen at some client, guess how long that takes? Usually a couple of weeks of intensive work of people going through and validating every single policy and whether that's valid or not. So what we're trying to do is to sort of, again, switch the narrative here and really put the business meaning to data and the business meaning to permissions on the data. My last point is we want to have a clear separation of duties. A lot of the clients that I dealt with are not only worried about external attacks, but they're also worried about internal attacks and data leaks. So giving the system administrator the ability to do assign permissions and have access to the system and do that sort of management sort of compromises that. And they would like to see a more clear separation of duties where I cannot give myself permission and access to access data. So I put in a simple table, left-hand side object-driven, so the way that we're used to assigning permissions, and on the right side, the data-driven way, and I put a small comparison between the two. So the current methodology is very similar to how we assign permissions on a Unix or a Windows system. We say, we put an ACL and a file that says user or group so-and-so has access to that file or that directory. It could be recursive or not. And the same way that we handle permissions on MySQL, I have to know the file, I have to know the directory, I have to know the group, and once all these come together, and then at that point I can go in and assign the permission. In a data-driven world, the permissions are basically tied to your tags, and once you tag something, then you assign the permissions to it. So I may not know how many tables that are associated with sales. I don't need to know that beforehand. I don't need to know how many columns are associated with HRs. I don't need to know that beforehand. As the data comes in, I can really just say, this is an HR data, tag it, and immediately my policy comes in. So immediately we see a reduction of the amount of work that our operations people and system administrators have to do in order to maintain the system up to date. Once that data, once the financial statements no longer become confidentials because now they're public, I don't have to go back in and change the permissions. I can just untag that data as confidential data, and immediately that data will be accessible. The next piece is, which I alluded to right now, is the object-driven way is very static. It does not change. Once I set an ACL on a folder, then the ACL is there. The contents of the folder may change. The classification of the data inside the folder may change, but there's nothing within the authorization framework in an object-driven way that will inform that change and adjust based on that change. But in a dynamic way, if the content of that folder change, and I change the business meaning or the tag or the classification of that folder, my permissions will be able to carry immediately to that. And again, that will not involve you going in and ServiceNow or Jira or whatever ticketing system you have, opening a ticket, telling your operation personnel, go into Ranger, change the permissions. The next point is system level context, as in, again, I have to know the folder, I have to know the table, I have to know the lower layer technology, where the other one is business level context, where this is sales data, this is HR data, this is marketing data. The next point is we're going to look at is one policy per service. How many here run the entire stack? So HDFS, HBase, Kafka, Storm. So assigning permissions right now, you probably have to go into every single repo and assign permission to every single repo, and it becomes quite hard for you to manage it across your entire stack. In a data-driven way, it's actually the other way around, where you can assign the permissions regardless of what the service is. So once I create a policy, and we'll see that later on in the demo, once I create a policy that is associated with one tag, I can tag my Kafka topics, I can tag my HBase tables, and I can tag my sales Hive databases, and I can tag a flat folder in HDFS. And that same tag, my same policy will be able to manage the permissions across all these. So I don't, again, reduce the amount of work for your systems administrators and operations people, because now they don't have to go into 5 or 6 different repos to achieve the same thing. The last point is who really should own this? The ownership right now and the people who are responsible for it are system administrators on operations, when it really should be owned by your data stewards or the line of business who actually own the data. As a system provider or as a system administrator, you're really just providing a service and you don't really have any ownership over it. How many organizations here have a data steward or a person within that level? A person who's responsible, like a chief data officer or something along those lines. So to draw it all out in a nice, neat diagram, I only picked a handful of services, but this will apply to any service that actually sits within the Hadoop ecosystem, whether it's HDF or HDP. What we have initially is you've got your sysadmin and you got your data steward. And your data steward you don't have to have that role defined within your organization, but it could be the person who's responsible for your data. So it could be the business owner of the data, or whoever has to sign off saying that this person has ownership over that data. Your sysadmin, if you notice here, essentially what they deal with, they only deal with the Ranger side. They do the initial setup. So when a new tag is enrolled onto your system, they will create the policy for that tag and assign the proper permissions, and then they walk away. It becomes hands-off. They don't have to go in and decide which folders and which tables and which columns are actually associated with that tag. That work happens with the data steward. The data steward will have access to Atlas, and through Atlas they will be able to go in and tag the appropriate data coming in. There is a piece here that's very important, is that it does not have to be from day one, but it's preferably should be that way. Your ingestion system, if it was able to inform Atlas, or you have a way of automating the process between your ingestion and Atlas to make sure that the data is up to date. As part of this demo, I will be showing you a wrapper that I wrote for a couple of my banking clients in Canada that they use, and they integrated into their ingestion system. I know a lot more tools now are starting to talk to Atlas directly. There's tons of work that's happening on the Atlas side to kind of streamline that process. But it does not have to be automated from day one. There could be an after the fact where the data steward comes in, so ingestion happens, go in and tag. And remember, if I have daily loads, then I do not really have to go in and change the tags constantly. Most of the time happens at the time when you enroll a new project or enroll a new piece of data. There is a daemon that runs that syncs the tags between Atlas and Ranger, and it's called tag sync. The Atlas here also acts as a way to catalog what you have within your environment, and you can search based on what you have in your environment. So next, what I'm going to talk about is how do you structure users in groups. There are multiple ways of thought about this. I'm only going to suggest one of them, and that's been the most popular one. But there are different ways, thought methods that you can follow to do this. Either you can assign them based on the line of business or the user group, or you can assign them based on the data types. So there could be a group that has access to PII data, and you can create a group called PII, and everybody who's a member of that group can have access to PII data. Or the other way around, where you can say, my HR department belongs to one group, and that's HR group. My sales department belongs to the sales group. You can have a bit more granularity, and then we're going to go through that and see how it works. What you also should have is a group for your platform and system administrators, and those are the people that generally have access to the OS layer, but not necessarily to the Hadoop layer, so they cannot exceed their privileges and assign themselves privileges to gain more privilege. Your Hadoop application support, and those are the people who actually have access on the Hadoop layer, and that way you can have a clear separation of duties, and one person cannot really exceed their privileges. The next one is data stewards. You can have one designate per line of business, or if you have, like some of you have, an actual office, chief data officer office, then those people will have access to it. One thing that you can also keep in mind, that Atlas itself, the permissions in Atlas are controlled by Ranger, so I can restrict who can edit information in Atlas. Therefore, I can say if I have multiple line of businesses and they give me one designate, I can limit what that person can do. Therefore, that person cannot, an HR person will not be able to go in and change the tags and information in Atlas for sales data as well. So that is one more layer of security that you have there where you can separate it. In an organization where it's one office that's responsible for all of it, that may not make sense because that one group or one person will have the full access, but you can have multiples if required and if that's needed. And then you can have a group per line of business or distinct user group, i.e. one group for HR, one group for sales. Or the other way of thought is that it's not really based on what department they're in, it's what kind of work they do or what they're allowed to do. I.e. I am allowed to see PI data where another person is not allowed to see it. And this is really based on how your organization functions and how you really split those roles and responsibility. Generally, ingestion and metadata, you should have a group or service accounts. If your ingestion is automated, put in that group, and they would really just have the basic right to bring in the data to your system. So Atlas has a very neat feature, and that's the inheritance of tags. And what that means is that if I tag an item, so let's just go through it. So the bigger tag is the parent tag, the smaller tag is a child tag, and then the two people are the user groups. What essentially I have my main tag called sales, and that's the, let's call it my VP global sales, and his people actually belong, or the data that's global to sales. And I have a sales department that's sitting in North America, sales department that's sitting in MENA, and then sales department in Europe. And if we were to think about this in terms of your tables or how your data is structured in your environment, you could see that the sales department in Europe really ingests their data and put it in this zone or this location. The North American side does that, and then the MENA side does that. The way that you could set it up, and at the end of the day, you want your global salespeople to be able to go in and see all the data coming in, regardless of where it came from. So if I tag a piece of data with the tag sales, any data that is sales NA, sales MENA, sales Euro will also have the tag sales. And this is what inheritance is. If I have a tag and I create a tag that's associated with it, or a child tag to it, any data that's part of the child will show up as part of the parent as well. The same concept applies here for HR. I just put two examples. There's HR management, and then there's an HR compensation and HR performance. If I tag my HR compensation data, as in this table is full of salaries and bonuses, and the other table is full of performance reviews, then I can separate the access layers, and I can separate and tag the data based on that. At the same time, my HR management will also have access to both HR compensation and HR performance. Atlas is wonderful and Ranger is wonderful, but these are tools that are still evolving. Some things are working amazing, and some bits that we need to wait a little bit, or you can augment the work yourself to get it to work exactly as it fits within your environment. So out of the box integration, there's a Hive bridge, as in any information that happens, any changes in Hive will be reported in Atlas automatically. So if I go in and create a table in Hive, that will show up in Atlas, the databases on the columns and such. Any scoop information that happens, that will also be reported, as in I connected to this DB2 instance or MS SQL instance, and I did this scoop job, and that scoop job really dumped my data into Hive. That the whole lineage will show up automatically without doing work on your end. There is an NiFi bridge, which is part of HDF 3.1. So all the processor groups and all the lineage and changes that happen will show up immediately without you doing any work. And there is one for Storm. If you notice in this list, HDFS is missing, HBase is missing, Kafka is missing, and there isn't currently existing hooks that can go in and create. For example, if I add a file to HDFS, that will not automatically show up in Atlas. Of course, if that file, there's a schema on top of it, then it will get registered as part of Hive. Or if that file gets created based on an i5 flow that creates those files, it will still show up in Atlas. But if I just go in HDFS DFS put file, that will not show up in Atlas. It's not the end of the world. There's a very lovely API that you can use. Unfortunately, the UI does not support the addition of entities for all of them. So it only supports some of them, so you can add an HBase table through the UI, but you cannot go in and add a Hive table through the UI, for example. Also, there is a limitation. The UI does not let you add custom fields, so it will just pick up from whatever in the meta store. That doesn't mean that you cannot have your own custom fields coming in. We'll be showing that in the demo as well, and to show you guys how you can do this. There's also the concept of you can create your own types and you can create your own entities. I had a client, a railway company in Canada, and what we've done is they take pictures of their track, and we were able to create a custom type in Atlas called track images, and then within the track images, every image that comes in through an IFI will actually create a catalog within Atlas. So you can search per coordinates. So if I want to know the coordinate, the picture of a specific waypoint across the track, I can actually search by the waypoint, and it will tell me what track car took the picture, all the metadata associated with the picture, what the weather was like on the picture, but that all was part of the ingestion process. So you can have that extra deep layer of cataloging and information based on what your organization needs. Unfortunately, it's not in the UI, but the API is very powerful and it allows you to do so. And you can do things like, we chained the images to our HDFS path because we put the images in HDFS. Therefore, it will immediately show that this image is sitting in this HDFS folder. So I can search the image by its metadata, or I can search the images by location in HDFS. We're going to start with the first piece of demo, and that is how do I register my service. So this is the assumption you have Atlas and Ranger installed. Essentially, you go in through the access manager, and you click on the policies, and it's that easy. You don't have to put in any extra configuration or information, and your service is registered. Here's the tricky bit that most people forget how to do. You have to edit the repo itself and tell it to talk to that tag service. So the mere fact of you registering the service to Ranger does not mean that the repo itself will actually start following that. So you have to go in, edit it, and inform the repo within Ranger that from now on, you have to start using this service for tags. And the default one will come usually like this. The next slide is I'm going to show you what the inheritance is like. So I created two tags, one called HR and HRNA, and then you can see that HRNA is derived. This is going slightly too fast. And you can see that HRNA is actually derived from HR. Next, we're going to tag some data and do some work on that data. So I have two tables in Hive. One is employees, and one is employees NA, North America. So I'm going to tag my employee with HR, and my employee NA, I'm going to tag it with HRNA. And next, if I actually do a search by tag HR, what I actually see is I'm getting both tables, HR and HRNA. And this is because we had that relationship of inheritance, and one tag is derived from the other one. So whatever work that happens in HRNA will be reflected in HR as well. Next, we're going to associate some policies based on our tag that we just created. So we're going to put the policy name, and then we're going to tell Atlas which tag it is. So this is the wonderful part that I've been telling you about, is that you have access to all the policies here, where you can add a single policy here. It could reflect information about HDFS, HBase, Atlas, KMS, Knox, essentially anything that's managed within Ranger itself. If it's managed within Ranger, if you have it registered in Atlas, that tag can manage the permissions across all of it. For this demo, we only did Hive, but it is possible to do it across the entire stack. And once you pick Hive, for example, you can come in and you still see whatever you see in Ranger in the normal repo when it comes to information such as what are my actions in Hive and what I can do with Hive. So here we've got select, update, create, exactly as you would have it. So I defined my permissions for this tag, and I told it that the user HR manager will have access to any Hive objects that is tagged with that tag. And if I click add, and then I have to go in and define my other tag, which is the HR NA. And I will assign the permissions to my HR NA user, and then I'm going to tell it for this specific data, and when it comes to the service Hive, give it a select access. And that's pretty much it. That's all you need to do. Once you create the tag and assign the permissions per tag, remember, if I have a million tables that are for HR, then I only have this one policy managing it. It could be a million tables in Hive, it could be 500 tables in HBase, and it could be 1,000 files in HDFS. I only have one policy to manage all of that, which actually reduces the stress a lot when it comes to the amount of work that your system administrators actually do, and also if any of you have DRs, what we notice is it significantly reduces the time and error rates when it comes to replicating policies between one Ranger and the next, because now instead of having 10,000 policies, that could be dropped down to something like 100, 150, and this is exactly what we saw happening with the clients that we've done this type of work with. So let's see it in action. So we tagged our data, we created our policies, and we did everything that we need to do. Let's connect to Hive and try to do some work. Can you guys see this clearly? I'll just stand here and do it. So what we have here, the first connection that we have, we're connecting to our Hive through Beeline, and then we have HR manager user connecting. That's the -n HR manager connecting to do some work. And what we're going to do is try to query the two tables that we talked about, which is the HR table and the HR NA table. So employee is the table that initially we tagged with HR, and and employee NA is the other one. The next step that we're doing is now we're connecting as the HR NA user, and if we try to perform the same actions, so we want to read the employee table, which has not been tagged with the HR NA tag, it tells me I don't have permission to do so. But if I try to access my data, which is HR NA, I'm able to access this data. So the whole point of this is to make the entire system scalable and make the entire setup very, very easy for very easy for system administrator to set up, and very, very easy for management later on. If you ask a business analyst to go into Ranger and try to understand what things mean and to tag and to assign policies, it usually doesn't end up pretty. So, but if you give them a UI that's Atlas, that's familiar to them, where they can read the description of the data and they can read some human type of identification to the data, then it becomes a lot easier for them for you to offload that management off to them, which it should be, since they are the owner of the data. At the end of the day, they are responsible for it. You as platform engineers and system administrators, you're responsible for the overall security and stability of the system. Next, what I'm going to show you is part of the code that we set up and the wrapper that it's on GitHub. Feel free to use it as well. So this is part of it, and what we've used to sort of input tags and attributes in Atlas and to streamline the entire process. So if you notice here, this is a JSON file that you feed into the script. You specify what the type is. In this case, it's Hive, but it could be any type within It could be any type within Atlas itself, so it could work for the HDFS or your own custom types. It has some logic. Once you put the word Hive, it will automatically understand. It will automatically understand that Hive has tables and columns, and you can, through one file, really go in and put the attributes across all the tables and all the columns. So the name is the name of the name of the database here. So for me, the name is default. I'm adding a custom attribute called zone, which is with the value development, and I'm adding a tag called auto-created. The beauty of the script is that those items do not have to pre-exist. There's a switch for you to say, if it does not exist, create it for me, which is really good on initial setup. But later on, you can turn that switch off to make sure that nobody goes in and adds extra attributes or extra tags. The next piece is that I define the tables that I want to add information for. So employee is one of them, and I want to add the business full description, business short descriptions, what the classification is, and what the country of origin is. And if we keep going through it, it will ask me more about columns as well, and what columns I have, and what columns I want to put in, and what information I want to add to those columns, and if there are any tags that I need to do. And I have my other table defined here as well, which is employee NA, and I want to run the same kind of setup there as well. So if we go to our Atlas right now, and we check Atlas, we'll see that I don't have those extra fields, and I don't have a tag called custom, auto-created. Once I run the script based on the JSON that we just created, it tells me exactly what kind of work it's doing. So I added a tag, and I added all the fields that I need. And at the end, it gives me a report telling me I was successful with 45 items, and I failed on 0. If I refresh the page, right away that I'll see that I have these extra fields showing up now, which is the business full description, business short description, confidentiality, country of origin, and all these fields are searchable. So you can search for a specific field in here. So if you want to see all the data that's with the country of origin of USA, you can do that as well. And this really helps your business owners or business users, once they go in and try to explore what data is there, to really get some context of what that actually means, because not all the tables have human readable names or something that's meaningful. What this does is it gives you the ability to go in and put that meaning to it, and you can give them search queries and examples that will tell them, give me everything with the country of origin USA. And if we continue looking through it, I'll see that I have an extra tag up there, auto-created, and that's the one we defined. It did not exist before we ran the script, but after we ran the script, we have it, and it's up and running. And if we look through our other table, employee, which had the country of origin Canada, it tells me that it has its own specific information, so you can do that separation. These attributes will not be carried over to Ranger. Only the tag information is carried over to Ranger. There are a lot more advanced topics when it comes to this. You can have extra filtering in Ranger depending on the attributes of a specific tag. So once I tag an element, I can give that element a specific attribute. As in, I can put stuff like a custom attribute for a tag called, let me pick one, access location. And I can specify that to be something like Canada, and I can add extra filtering when it comes to Ranger, that if the attribute, so not only if the tag exists, but also if the attribute for that specific element is this attribute, then you can add extra filtering rules in there as well. So in summary, what are we trying to achieve? What we're trying to achieve is really giving ownership to the people who need to own this, and allowing them and giving them the tools to perform whatever task they need to do successfully, and giving them the ability to do this on their own without the interference. The other thing that we are achieving the other thing that we're achieving is we're giving them also the ability to do the work. We're reducing the amount of work that our system administrators have to do, and we're really streamlining your entire data lake. Our system administrators and platform engineers are amazing people, and sometimes things don't progress as quickly as possible, and the reason is they're sometimes overworked, and there's a lot of tasks that happen to do, and a lot of projects coming in, especially when you're initially starting up a data lake and you've got 100 sources coming in, and you have to manage the permissions across the 100 sources, and each source could have 100 files, and that amount of work can create a huge backlog. That should not be there, that is not necessary for them to be there. And then the maintenance of that permissions becomes a lot difficult for them because they might not know what that specific data means. And you're giving them the responsibility of maybe trying to understand what it means. I have other projects as well that it's all on GitHub, it's open source, you can deal with it. One of them is Ranger multi-domain sync, where you can sync multiple Active Directories to Ranger. There is a cloud break with a shared Ranger instance and shared Hive metastore where you can spin multiple databases managed by multiple clusters managed by a single cluster. Ambari SSL Wizard. Who here struggles with SSL? Isn't it the biggest pain in the world? Unfortunately, 10 years ago, I was given the responsibility of managing SSL, and it made my life miserable. So I collected all my knowledge and work and put it in simple scripts that will handle the entire setup for you. And the last one, which still is in beta, is to build Docker, to build dashboards for your Hadoop cluster. That eventually will get integrated back potentially into SmartSense, and that includes like indexing your entire HDFS paths. That way you can search for a specific file and figure out the sizes of specific directories. It's not a big deal when your FS image is small, but when you're dealing with 24 gigs of FS image, trying to do DU recursive on something usually takes days. So that's kind of the work that we're doing. That's the kind of work I'm doing. Any questions, comments, concerns? Yes, sir. Yes, you can do column-based, and you can do masking as well. So these policies will apply for anything that's within Atlas itself. So Hive column is part of the types within Atlas, so you can assign permissions against it as well, and you can do dynamic masking. So you can create a tag called PII, for example, and say anything that's PII is masked, regardless of what it is. But that's dynamic masking, so if someone has access to the underlying HDFS file, they'll still be able to read it. Just make that distinction clear. Yes, sir. Yeah. So the question is, how do we break the system, essentially? Can I tag something and gain access to it, right? In general, your data steward does not actually have access to the cluster. The only thing they have access to is the Atlas UI. So even if they tag that piece of information, they don't know what are the groups associated with that tag. And that information really sits with your system administrators. So having a tag by itself, it does not mean that a specific group has access. You have to, like we saw, you have to say that for this specific tag, this user and this group have access to the information tagged with that tag. Generally, that's where the line of separation is. If you are allowed to do the tagging, you don't generally have access to the cluster. Because if you're a data steward or if you work for the chief data officer, then you're not the one running queries and you're not the one running SQL. You're not the one interacting with this cluster directly. You're more on the administration side. Yes, sir. So if there's a policy that's tags based and there's a policy that is statically based, is that what you're asking? Okay, so I have two tags. One tag says I have access, and the other tag says I don't have access, and somebody tagged the same piece of data with uh, with those two tags. Do I have access or do I not have access? The general rule of thumb is that the deny will always win. So it's access of the least privilege. So if there's a deny, the deny will always win. So there are, yeah, so I think Amazon Glue is one of them, AWS Glue, and a few other tools that are trying to go in and understand what data is, and there's Waterline, I think, is another one of them. Um, those tools, I think they're still in early phases, and the data is quite complex right now in the classification. And the other issue with them, from my experience, is that they are sort of situated. So with Amazon Glue, for example, it will only go in and read S3, but it does not have an understanding of Kafka topics or something of that magnitude, right? The same thing with Waterline. These general tools just look at one piece. Maybe in the future they'll get better and they'll add extra support to it. But that does not distract from the value of Atlas itself as the business gateway, the business catalog really to your entire data lake. From experience, without really having Atlas, it's the difference between having a data swamp and a data lake where everything has a real business meaning and a business value to the data that you're doing. Thought someone had a question on this side. Yes, and then we'll get to, yes, sir. Yeah, go for it. Um, from what I know, the static rules will win first, and then the tag will win. Oh, yeah, sorry. The question was, if I have a static rule and I have a tag-based rule, which one would win first? The static rules would win first. And if you have, for example, I tagged the column, but I did not tag the table, then that will not work. I have to tag the table and the column for access as well. Because I may have access to the column, but I don't have access to the table, therefore I cannot query the table. Yes, sir. Not in a row. In a column, yes, but not in a row. There is row level filtering that you can do in Ranger when it comes to Hive, especially in Hive columns. You can associate tags with certain low level filtering, the policy, but the tag is just an identifier for the data. It does not control what filters you apply to that data. That's really on the Ranger side. Once you go and set it up, once you go to masking, click on masking, and you can specify low-level filtering, and that works for both dynamic and static policies, where you can have low-level filtering. Any other questions? Yes, sir. As far as I know, it's in the wiki, so the Apache wiki for Ranger and Atlas as well. I don't know where else they're documented. I usually just go to the code and figure things out, but that's not generally a very sustainable thing to do. But It's a bad habit of mine. Yes, sir. Say that again. Yeah, you can. I don't know of any limits in terms of how many you can inherit. So one can inherit the other, and inherit the other, then inherit the other, and this really comes in handy when you're doing like nested data and that type of stuff, where you can say like HR North America, HR Canada, HR US, HR Mexico, and then California, New York, and that type of sort of all the way down. If you need information that gradual, or the data that you have stored is actually that gradual. So if it's one giant HR table and all the countries and globally is stored into that table, then you're only tagging that one table. You're not really, but if you have multiple tables, and then you can spread out your tags. But if it's one large one, then it does not make sense. And again, it depends on how your ingestion works and how your data is spread out. It has to be an identifiable, like table, column, database, file, topic, but it's not really that piece of the table or that piece of the topic or that piece of the file. It's full whole things. All right, so I think that's it for questions. Again, thank you very much for attending, and I hope this becomes of value to you, and you can really help your organization and really push through and speed things up. Thank you again for attending DataWorks Summit. It was really a pleasure to have you all visiting us here, and if you have any questions, I should have written my email down, but let me see if I can just... That's my email. Feel free to contact me. Quite active on GitHub as well. If you have any ideas, anything you want to run, please feel free to do so.